Hey everyone, in this video we are going to understand what the inverse of a function is, and most importantly we will build a strong intuition of how inverse function works. So by the end of this video you will know how to find inverse and when they exist. Before understanding inverse of a function, let's first understand what functions do. So think function think of function as a machine which takes an input, perform operations or transform input and give us the desired output. It takes input, perform operation and give us the desired output. So the inverse function just do reverse of it. It takes output, perform reverse operations, or you can reverse transformation and give us the value of input. So this is what an intuition of how inverse function work. Inverse function work in reverse, taking the output back to the original value. Let's take an example to understand how it works. Here is the quick example. Consider this function fx equal to 2x plus 3, and let's say the output of this function is 11. So what was the original input value for the output? 11. So we will solve this equation by putting fx equal to 11 and solve this equation. On solving this equation, we will get value of x is equal to 9 by 2. So this is how the reverse phenomena work. As you see in this example, we have given an output and we have to find the input. So this is what an inverse function do. Now let's jump to the formal definition of inverse function. So now let's understand when a function is said inverse. A function is the inverse of a function when its composition with a function brings back to the value of x. So now let's understand this with a simple real life example. Suppose there are 2 points A and B. Take point A as an input and we have to reach at our desired output point B. So for reaching from point A to point B, we will use a function, let's say bus 1 B1, which take us from point A to point B. And there is another function or bus 2. What it does, it takes passenger from point B to reach at point A. So if an person takes a bus from point A to reach point B, and again he takes the bus B2 from point B to point A, it will reach to its initial value. So this is what an inverse composing inverse function with a function do. So how can we write this in this particular form is, suppose there is a passenger X who takes B1 bus, and then after reaching at point B, he takes bus B2. Then unfortunately he will again return to point X, or you can say point A. Here the value of X is A. So this is how we can say that whether the function is inverse of that particular function or not. Now here are the steps which we follow to find an inverse of a function. So the first step is we have to write the equation in form of y is equal to fx. This is just rename the function notation to make it easier to manipulate. If we have given an equation fx is equals to 2x plus 3, so what is the first step is to replace fx with y and write this equation as 2x plus 3. Then step 2 is to solve this equation for x. To solve this equation for x. And here as you can see, this means is rearrange the equation to isolate x again, which means we have to solve this equation for value of x. So for solving this equation for value of x, it will be this: y minus 3 divided by 2 is equal to x. Now step 3 says swap value of x and y. This is the core idea of inverse. Input becomes output and output becomes input. What is meant by this line is what we have discussed above. In inverse function, the value of output of a function is behave as an input, and the output of original function is behave as an input, and the input of original function behave as an output for a reverse function. So this is what we follow the third step to solve and find the reverse of a function. So we will simply swap value of x and y. Now the final step is to replace y with f inverse x. This return the equation to prepare inverse function notation. So we will simply replace y with f inverse x and we will get our inverse function. So these are the 4 steps to find the inverse of any function. Let me revise once. What we have to do is, first we have to write equation in a form of y is equals to 2x plus 3 or whatever the equation is. We have to replace function fx with y is equal to 2x plus 3. There is nothing, just to make it easier to manipulate. Then what we have to do is we have to solve this equation for x, for a value of x. Once we solve this and get our expression in form of x is equals to something, then we have to swap the value of x and y, and this is the main step. Why we do so? We do so because in function and reverse function the role of output and input get reversed. After that we have what we have to do is just replace y with an inverse function, because the function which we get y is equals to something is our required inverse function. Here is the example which I had already discussed above. These are the step-by solution. First, what we have done, we have replaced fx with y. Then we have solved this equation, swapped x and the value of x and y, and we have get our desired inverse value. So these are the steps which we have to follow to find the inverse of any function. Now let's understand the graphical meaning of what inverse of a function means. So how to find an inverse of a function, graph of inverse of a function? We do it by just getting the mirror image of a function about the line y is equal to x, as you can see here, y is equal to x line. So the graph of fx and f inverse x are the mirror image about the line y is equal to x. This visual symmetry confirms that for every point a comma b on fx, there is a corresponding point b comma a for an f inverse x. What does this mean is, when we take the mirror image about the line y equal to x of any function, then the image which we got is the image of the inverse function, is the image of an inverse function, and the coordinates of that inverse will just simply get reversed. Means, suppose if there is a function whose graph has coordinates a and b at an, so after reversing or taking mirror image of that graph about the line y is equal to x, we will get the graph of reverse function which have coordinates b comma a in that particular graph. So this is what the graphical meaning of reverse of a function, or we can say this is how we can find the graph of inverse of a function. We don't do nothing, we simply just do we just simply take mirror image about the line y is equal to x or y equal to x of particular equation graph fx to get its reverse equation graph. Now you must be thinking, when does inverse exist or the inverse function always exists? So the answer for this question is, the answer of this question is no, it not does always exist. There are certain conditions which must be followed to find the, the inverse of a function, and the condition is for a function to have an inverse it must be bijective. By bijective what we meant is function should be 1 to 1 and on 2. Now let me explain what is meant by 1 to 1 and on 2 functions. 1 to 1 function are function where each input has unique output. No two different input map to same output. What is meant is here for any input value, let's say x1, there should be a unique output value y1, and for any unique value x2 there should be a unique output value y2. If the function produce same output value for two different input value, then we can say that the reverse of that particular function will not exist. So these are the first condition. This is the first condition of function to have an inverse. Now let's understand what is meant by onto. Every element in codomain possibly outputs is mapped to by at least to one element in the domain. What is meant is, for what by this meant is, for every value, for every input value, the produced output should be from codomain. Or in simple way we can say that the output produced by a function should have at least one value in codomain. Suppose we takes an input x2, the output which produced by taking input value x2 should have at least one value in its codomain. If it do not exist from its codomain, then we simply say that the function do not have its inverse. So these are the two primary conditions to determine whether the function have their inverse or not. There is also a graphical test which is used to identify whether the function has inverse or not. So this test is known as horizontal line test. What it do is we have to just draw an horizontal line, cut the graph. If that particular horizontal line cut the graph more than once, then we can say that the function is not 1 1. And if the function is not 1 1, then we can say that the inverse of that particular function will also not exist, because for having an inverse the condition is it must be 1 to 1 function. So if a function cut by an horizontal line multiple times, that this function cannot have its inverse form. Let's understand it with a simple example. Let's suppose there is a function x square which is a general standard polynomial function. So the graph of that particular function is something like this. It is not getting properly. Let me zoom in to understand. This is an y coordinate, this is an x coordinate. So if we do horizontal test, in horizontal test as we discussed above, we just simply draw a horizontal line, and then you can see it cuts that particular graph multiple times here and here. So since it cuts this particular graph multiple times, so we can say that the inverse of that function does not exist. So this is very important test we can say, which is used to identify whether the inverse of that particular function exists or not. You can also check this with an example of onto. I will explain this. Suppose f(x) is equals to x square. So this function generally range, let's suppose, from R to R. What does it means? This is denotes as domain, means it can take any real number values, and this is its codomain, or we can say that codomain range. So for every real value, it must produce an real value. What is meant by this expression? But if you see this function carefully, you will observe that this function will never produce a negative value, which means it contradicts its codomain feature, which is an onto function. What does it mean? Every input value must have at least one value in codomain, but in real number, all real number or real number negative value also come. But here in this particular function, it will not produce a negative value because the value power of x is square. So as you can see, it is not falling onto function. So we can also from here say that this function fx is equal to x square will not have its inverse, function. Now I have also mentioned few examples to understand it and relate it with the real operation which are generally performed using inverse phenomena. Decoding messages. Inverse and crucial in cryptography to encrypt and decrypt information. This is an advanced level topic which you will understand in your higher classes. So this is the example where inverse phenomena use. And temperature conversion. In this, as you see, we often formally convert temperatures between Celsius and Fahrenheit with the operation which we use to convert temperatures between Celsius and Fahrenheit are inverse function of each other. Undo operations. For undoing operations, we use inverse function, as we discussed above, that inverse function undoes what function does. So inverse phenomena is used to undo the operations. Basic cryptography. This particular example you will study in your higher classes and understand the significance of inverse operation in this function also. So yeah, this is what the inverse function is. I hope you understand how to find inverse function, when that is exist, and all of this. If this made sense, you are well on your way to mastering inverse function. Thank you for watching.